Hi, we are Team 12, and this is our ME452 interim presentation for the analysis and redesign of a can opener. So how can openers work? They provide an easy way for people to open cans that do not have a pull tab. They work by turning a knob by hand that spins a set of gears on the product. And on one side, a knurled disc moves relative to the can opener, and on the other side, a cutting disc cuts through the actual metal top of the can to open it. So we estimate that the annual production volume of can openers is greater than 6.8 million because in 1972 there were 6.8 million can opener units sold, and we know that the compound annual growth rate as of 2021 was around 8% per year. So looking into the primary and secondary customers, the primary customers are home kitchens, mainly people that need to open cans in their home kitchens for food. They relatively use the product a light amount because they don't need to, and because of this, they don't need to rebuy the product very often. On the other hand, commercial kitchens need to buy more units of the product, and they use it much heavier and more frequently. And because of this, they wear down at a faster rate and they need to be replaced.
Here's the exploded cat for the can opener. As we can see, there are two long handles. Then there is the actual crank handle that when turned, turns a set of gears. There is the part number 5, which is the rotating gear wheel. It pushes the can relative to the can opener. And then there is part number 2, which actually cuts the can.
This is our fast diagram breaking down the functionality of the can opener. Most of the functions relate to cutting open the can as it relates to opening the can. So it needs to attach to the can by aligning to it and gripping it, and then piercing the surface to get into the contents of the can. This is our first assembly sequence. We begin by grabbing the lower frame portion. From there, we attach the gear and a spacer of that gear to the lower frame. From there, we attach the handle grips. On top of the gear and spacer, the cutting blade gets pinned down. Then on the other end, with the upper frame, the rotating gear, and handle clip are attached and put together with the lower frame pivot with the pivot pin. And finally, the crank handle is attached. Moving on to our second assembly sequence, we again begin with the lower frame pivot, attaching the handle grips and the handle clip. Then, as opposed to the first assembly sequence, the upper frame gets put on first. From there, the gear stacks on each of the frames gets put together finally with ending with the crank handle being put on. Looking at the two sequences side by side, sequence 1 has higher scores and ease of handling and transferring, as the two parts are kept separate before putting together. So that is the sequence we're moving on with.
Okay, now we're going to be moving on to the FCMM. This is the function component mapping matrix where we map the components of the can opener to some functions on the fast diagram. So as you can see, a couple different components can be found in the same product function. For example, if you look at the enhanced product function, many components can be found there as well. Next, this is our bill of materials. So like we said earlier, we assumed an annual production rate of 6.8 million units. And then we also made the assumption that the assembly would be done manually. So most of our components were either machined or injection molded. And then next we have the quad chart classification. So here we have a 4x4 of where different components fall. So as you can see, a lot of components have a low manufacturing cost and are low in functional importance. For high functional importance, low manufacturing costs, we have things like the crank handle, can cutting blade, can rotating gear wheel. And then for high manufacturing costs and high importance, we have things like handle grip, the upper and lower frames.
This is the assembled version of the CAD. You can see the two handles that pivot around, and then the knurled wheel that moves the thing, and the cutting disc, along with the twist knob on the back, the crank handle.
Here we can see our functional differentiation table and our common component table. So multiple common functions go between the design for both of our customer groups. But the main differentiation in terms of the function between our two customer groups is for our secondary customer group, commercial kitchens, they need to be opening cans at a faster rate, which means they might need to adjust the speed and change the way in which we maintain control. And that maps to the module for this design, which is our crank handle part that we use to break into the different product families.
Yeah, so the original design has sort of a twist knob where you twist with your wrist, and the additional design that we've come up with is a crank handle where it's more of an arm-based motion, so to make it a little bit easier to open the can and make it faster. They both interface with the sort of twist pin that spins the gear on the front, and that's the same interface for both of those. And the assembly of these is nice because everything can be the same up until the point where you attach the crank handle at the end, and you can sort of, match whichever one you want based on the variant. So thank you.